welcome to our session of Project Teach. We're just going to give everyone a chance to settle in before we get started. So feel free to use the comment box to let us know where you're calling in from, yourself, while we just get started.
Shauna, there's a bit of an echo.
Is there? Okay, I'm just going to remove our speakers for now.
You're good now.
Okay. Oh, there we go. It's a little bit quieter now, so I think it's just having all of those speakers live. So I can see that we're having a little bit of trouble with the broadcast coming through on the Facebook feed. So Nithya, if you just want to take over welcoming people as they trickle in, I'm just going to see what I can do about that.
Okay, will do. Thanks, Shauna. Hello, everyone, and welcome to Project Teach, talking about ecology and aims for conserving habitat. My name is Nithya Chari Harris, and I am a director of the Coexisting with Carnivores Alliance. I'm joined today by our panel of 3 experts who I will introduce shortly, and by Shauna Dahl, Gulf Islands Forest Project Coordinator with Rain Coast Conservation Foundation. I will be facilitating today's discussion. Today's topic is fostering forest resilience in the climate change era. We wish to express our gratitude and appreciation to be here on the unceded territories of the Sauk Nation and the neighboring Patida and Chiano nations, and of the Songhees, Esquimalt, and the Wasanic nations. We would also like to recognize the dozens of distinct Coast Salish and Nuu-chah-nulth nations on whose territories most of us are in attendance today. Also, it is important at this time to give our gratitude and appreciation to the land, the waters, and the air, and all the diverse life within them that sustain our lives. I would like to invite everyone tuning in today to take a moment to remember whose land they're calling in from. And we welcome you to make your own land acknowledgement in the chat box. Over to you, Shauna.
All right, so just a few housekeeping items. Audience members are tuning in today using mostly YouTube right now, I think. We're just trying to troubleshoot what's going on with the Facebook chat. But those who are tuning in can participate by entering any questions into the chat on either platform. We'll be monitoring those chats and collecting questions to pose to each expert at the end of their presentations. There will only be time for about 1 question before we move on to the next presenter, but we have time scheduled at the end for discussion. So if we don't get to your question right away, don't worry, we will get to it at the end of the session. So with that, we'll turn our things over to our first presenter, Nithya, if you want to read out that bio.
Thanks, Shauna. So Dr. William Hammond, who is a plant ecophysiologist, global change ecologist, and head of the EcoPhys lab at the University of Florida. Broadly, he's interested in how plant vascular systems react to extreme environmental conditions, especially regarding their function, dysfunction, and the limits of survival. His work researching plant vascular systems aimed to bridge basic and applied research by identifying how physiological traits coordinate to confer drought tolerance and/or resistance, and developing novel ways to sense plant dysfunction for improving plant survival in our warming world. Welcome, Dr. Hammond.
Thank you so much for having me. I'm going to go ahead and share my screen real quick if you'll let me know when it's visible.
It should be up there for you, Bill.
Awesome. I see it now. Well, thanks again for the invitation to speak today. My name is Bill Hammond. I'm an assistant professor of plant ecophysiology at the University of Florida. And I'm going to speak with you about plant death in the Anthropocene. This is a topic that I think it's really timely to be talking about because Earth's forests really do face grave, that is life-threatening challenges in the Anthropocene. And of course, while this begins with heat and warming, there are other stressors like drought, increased risk of wildfires, insect outbreaks, damage from storms like wind and lightning, and even amplified pressure from pathogens. And so the challenges that forests face are not only grave, they're really complex. And because I only have just a few minutes with you today, I'm going to zoom in on just heat and drought. But I want you to keep in the back of your mind that these are not the only pressures that forests are under, and that these systems are really complex, and these different threats are often even synergistic with one another. The bulk of what I'm going to tell you about today is from a paper that we just published 2 months ago in Nature Communications, titled Global Field Observations of Tree Die-Off Reveal a Hotter Drought Fingerprint for Earth's Forests. Before I go any further, I want to acknowledge that while I led this work, I did not act alone. My co-authors did amazing and incredible work to help gather this global data set of Earth's observed forest mortality. And so if you like anything you see, it was probably them. The major questions we were trying to answer with this work, and where we'll depart from in today's talk, is we really wanted to know for global forests, how hot is too hot and how dry is too dry? And this is an important question to answer because drought and heat-induced tree mortality has occurred all over Earth. Here's a view of that from Sequoia National Park, here from Texas, where the 2010 and 2011 drought claimed maybe 300 million trees. Recent mortality due to hotter drought, exceptional heat in Germany in 2019, in places that you may not think about drought, like Costa Rica, mortality in Southwest Australia, in really wet forests like the central Amazon, and even really big old trees like these Atlas cedar in Algeria can succumb to hotter drought. And so it's a global phenomenon. And when I say tree mortality in this presentation, I'm mostly talking about what you see here, these pulsed events of a high proportion of a forest undergoing mortality all at once. And this is another reason we should be thinking about this problem right now, is that in many places it's getting drier. This recent paper that came out, I think a month or two ago, also was able to show that the most recent 22-year period was the driest since the year 800. That means drier than we've recorded in the last 1,200 years. And it's often not just drought, but hotter drought. Most droughts are happening at times when it's hotter. And this map from a paper out last year by Elizade et al. Shows us that 42% of the contiguous United States had a significant tendency towards droughts occurring when it was hotter. So we see a lot of like compound extremes, we call it. And so what we did in this work, the first thing was to collect all of the observations in the peer-reviewed literature we could find from 1970 to the present, and gather information about where on Earth trees have died during hot drought, and also precisely when those observations happened. This database is a result of the observations in the literature, but it required a lot of reaching out to study authors to get precise coordinates, because we really wanted to know where and when these pulses of forest mortality had occurred. And on this animation I've been playing for you now, we're up to 2018, and you can see that across the Earth, all forested continents have observed these kinds of pulsed hotter drought mortality events at some point. And this is just a view of the whole map with a few insets. One of the first things we wanted to look at was to ask, well, which biomes have experienced this climate-driven tree mortality? And a way to think about biomes, on the x-axis of this figure here is an annual temperature in degrees Celsius, and then on the y-axis, the annual precipitation from almost none to over 4 meters. And here you have the different biomes that were drawn out by Robert Whitaker. If we add those 1,300 plots of Earth's observed forest mortality events here, we can see that all forested biomes have experienced elevated tree mortality associated with drought and or heat in the last 48 years. And so what this means is that really, eventually, no matter what the average climate of a forest is, a hotter drought could push the forest to a point where a large portion of trees could die. And I think it's just worth noting that the temperature gradient that these mortality events covers in terms of annual temperature is over 30 degrees Celsius, and it occurs in forests as dry as just a few hundred millimeters a year to forests that have up to 4 meters of rainfall in a year. And so trees are dying on every forested continent and in every forested biome during extreme drought and heat. But one of the things we really wanted to ask with this now globally assembled data set was, is there a common climate signal for tree mortality? That would really be to say, what is the answer to our question of how hot is too hot and how dry is too dry? To give you an example of how this works, let's zoom in from the world to a single plot. Now we're looking here in Palo Verde National Park in Costa Rica, plot supplied by Dr. Jennifer Powers at the University of Minnesota. And there was a mortality event here in 2015. Now that we've taken the time to build this database of exactly where and precisely when the tree mortality events happened, we can look at climate indices like this Palmer Drought Index, where the red means drier. And we see that in 2015, this site was not only at a near maximum intensity for drought stress, but in a really long duration drought. And so we can now try and look for that climate signal to answer our how hot and how dry question. And specifically, even though this is a drought example I've given here, I just want to call out that, again, really wondering what's the effect of warming here. And one of the reasons that I keep bringing this up is I'm a plant physiologist. And so I spend my career thinking about how plants interact with their environment and how their physiological processes make it able for them to persist in a wide range of conditions, and eventually how that can cause them to dysfunction or even die. And I think of warming as posing a triple threat to plant survival. It amplifies atmospheric drought, it makes the air drier, it intensifies soil drought, it dries out the soil moisture, and there are direct effects of heat stress. In the northwest of North America during last summer, there was an exceptional heat dome event where even trees that sometimes had wet feet were still seeing foliar scorching as a result of the intense heating. And so our hypothesis with this database assembled was that when we go looking for this climate signal, it's going to be the typically warmest and driest months that may become hotter or drier. So when the extremes get even more extreme, that's when we expect to find these tree mortality events. And so the questions we wanted to ask to test that hypothesis were, could we detect this global hotter drought fingerprint, a set of climate variables across 48 years of Earth's forest mortality? And then second, if we can, we wanted to ask, well, how would further warming of the Earth affect the frequency of these historically lethal hotter drought conditions, the conditions that were happening the mortality year across Earth's forests? The analysis is a little complex, so I'm going to step you through these figures, axes, because we're about to look at a lot of them. On the left here, I'm going to show you these 6 climate variables. The top 2, maximum temperature and vapor pressure deficit, are really like our warming metrics. The bottom 4 all have to do with moisture in some regard, like the precipitation or soil moisture or that drought index I showed you. And up at the top of the plots, I'm going to show you the year we're talking about. We're going to look at 9 years together here, starting 4 years before mortality, and we'll go to 4 years after. So I've taken all the mortality years from 1970 up until 2018, and I've aligned them so that all the events are centered on their mortality year. When I show you the data, if it's average, if it's not different from the long-term trend, it's going to be in the middle. If it's a cooler or wetter than long-term, it's going to be on the left side of the plot and be blue. And if it's warmer or drier, it's going to be on the right and red. So when we're looking for that climate signal of hot drought, what we're looking for is something that'll be a lot of red dots on the right-hand side here. So 4 years before the death of forests across these 48 years, the average conditions were actually pretty much wetter and cooler. Precipitation was normal, but the rest of these metrics are in the blue, right? 3 and 2 years prior, things are pretty average. But a year before the mortality year, we see for the first time all 6 of these climate metrics in agreement in the same direction, towards warmer and drier. And the mortality year, which I'll go to next, is when this kind of reaches its maximum. And so this is what we think is the answer to that, how hot is too hot and how dry is too dry. These z-scores are kind of in units of standard deviation. So when it gets this much warmer and drier at the same time, we think this is a really difficult time for forests. And that's why we see this signal show up whenever these pulses of elevated forest mortality are happening. And this is something we call a hotter drought fingerprint. A year after that warm, dry signal hangs on, even though precipitations return to normal. And then 2, 3, and 4 years after, things kind of resume a bit more of the normal pattern that we see when we look further in either direction. If we zoom out, we can see that hotter drought fingerprint is really kind of the most concurrent intensification of these 6 climate metrics, but it's shouldered by a year before and a year after also being kind of hot and dry. When we get to discussion, I'd love to go into that more if there's time. The second question you'll recall was, what about further warming? As Earth continues to warm, what might we expect? Well, I told you that the further warming is going to amplify this warming triple threat. And so the soil's going to get drier, the air's going to get drier, and then the heat is going to be stressful on its own. We use some climatologies that simulate a +2C or +4C warming of Earth's climate from a service called TerraClimate, built by one of our co-authors, John. And this allowed us to look at the frequency of mortality year conditions. So how often does that fingerprint show up in a decade? And under the observed climate, which is shown here in 0.7, if Earth is allowed to warm to 2 degrees C warmer than pre-industrial, we'd see mortality condition frequency increase by about 22%. So 22% more often conditions that have led to the death of Earth's forests in the past. Of course, if the Earth warms even further to plus 4C, this number goes up to 140%. So you'll notice the line connecting these bars isn't straight, it's a curve. And we all learned something about curves and how they should be avoided when they have to do with mortality, thanks to coronavirus. And so I think this is some evidence from globally distributed forests that have had to go through mortality due to hot drought in the past, showing us that there's a lot of reason that we should put all of our effort that we can into limiting warming to no more than 2C. A lot of forest health might depend upon it. Here's that hotter drought fingerprint, and I know it's kind of an abstract concept at the whole planet level. So if we zoom into a single plot, these are demography plots in New Mexico, where the fingerprint here was defined in 2002. This is an evergreen pinyon juniper forest that by 2004 looked not so evergreen, a massive mortality event. Our model showed with the fingerprint that it should happen again in 2011. And we didn't have a photo from that year, but this is a forest that made it through the 2002 event, but suffered extensive additional mortality during the 2011 drought event. So what it looks like under the climate warming is that instead of 1 extra mortality pulse, there could be 3 at plus 2C at this site, or 5 at plus 4C. So that's something to think about. The data from this study is all available at tree-mortality.net, which is the International Tree Mortality Network's webpage. There's an interactive version of the map where you can query and download the database or upload your own observations of forest mortality going forward. We hope this can be a nice resource for the research community. I'd like to thank all the many sources of support, especially from UF, my employer, and everyone else who makes the science possible. To thank the members of my lab who study how trees die and are still working on it right now while I'm giving this talk. And then finally, happy to take a question now and looking forward to the discussion later. Thank you.
Thank you, Dr. Hammond. My goodness, that research is so relevant to our times. So the first question is going to put you on the spot, actually. We have a lot of people here from different walks of life. Some of them are politicians, and we have some scientists. We have people in NGOs. So knowing what you're talking about, mortality conditions, what should governments, either the federal, provincial, or municipal levels, be doing right now to counteract these tree mortality conditions in the upcoming years?
This is a really great question. What I'll tell you is that the universal thing that all governments, no matter your local forest's current state or projected future state, we're all on the same planet. I really firmly believe the most important climate action that we can take first and foremost is to limit emissions. Trees are wonderful and magnificent organisms that can capture carbon from the air, but they also respire it. And if they die, we won't be able to plant our way out of this if we don't first limit the foot on the gas pedal that is our continued emissions, And so this has got to be, I think, issue number one. There are lots of other management actions that could be considered. There are breeding program actions that can be taken. As a physiologist, I'd try and test and study which trees would survive the longest. And so there might be needs to think about the right plants to even reforest with after events like these. However, I think all of that kind of pales in comparison to policy action number one, which should be really focusing on limiting further warming of Earth by curbing emissions, because that figure with the curve, if it doesn't speak to you in any other way, it's the trees speaking through their own mortality that more than 2C is probably not going to be a situation we want to be in with our forests. Yeah.
Absolutely. Thank you. I think your slides really emphasize that fact. Really appreciate your presentation. Thank you.
Thank you.
Okay, I will go on to our second presenter. Dr. Daniels is a professor in the Department of Forest and Conservation Sciences at UBC. Her research strives to advance fundamental scientific knowledge on forest dynamics, which is imperative for conserving and managing contemporary forests and adapting to global climate change. This research characterizes how natural disturbances, humans, and climate interact to drive temperate forest dynamics and resilience. Dr. Daniels' enduring partnerships with local to national governments, environmental organizations, forest management companies, community forests, and First Nations have helped her to translate scientific advances to operational conservation, restoration, and management policies and strategies. Welcome, Dr. Daniels.
Okay, can you hear me now?
Yeah, we can hear you. You're back into that. Oh, your presentation just disappeared.
That's okay. Sorry, I'm just going to open up those slides again. Sorry about that delay.
No worries.
Let's get us into full view.
Oh, there
Okay,
you go.
well,
Perfect.
thank you. Thank you so much for the invitation to be here. I'd like to acknowledge that I'm coming to you today from the University of British Columbia, where I'm on the unceded traditional territory of the Musqueam, Squamish, and Tsleil-Waututh First Nations. I want to share with you some thoughts about our coastal forests and climate change resiliency. And I'm going to change kind of the scale at which I'm thinking and the concepts from Bill's excellent presentation, talking to us about the consequence of drought and extreme heat events on our forests globally. And think about how that type of climate change, what it is superimposing upon in our forests of British Columbia. My theme today is about paradigm shifts, how we go from our past paradigms to deal with the challenges of today's environmental change. So I want to start with this Gestalt figure and ask you, can you see the old woman? Can you see the young woman? The old woman is looking towards us. She has a hooked nose and she's got her mouth open. She's looking down. The young woman is looking away from us. She's got a scarf and a feather in her cap. She has a mole on her cheek and her eyelashes are long. This image shows, embedded in simply one image, two very different pictures. And I want to use it as an analogy in the ways that our understanding of our forests, and in particular our coastal forests in British Columbia, have changed through time, and how I believe we need to change again to address the challenges that are coming towards us with global climate change. As just a little bit of a preamble, I wanted to point out that our coastal forests are highly complex. And they range in terms of their types, with latitude, with elevation, with distance from the ocean, and also with rain shadow effects. So at the highest elevation, we have our mountain hemlock zone, our subalpine elevations along the coast that transition to a non-forested alpine ecosystem. The majority of our forests that have been so contentious when we talk about management and conservation, in particular of old growth, are our coastal western hemlock, the low to mid elevation forests that have been intensively managed. On the windward side of the coastal mountains, we see that these are wet, true coastal temperate rainforests. And then we get on the east side of Vancouver Island, this very narrow strip of coastal Douglas fir systems on the southeast of Vancouver Island and the Gulf Islands that are strongly influenced by the rain shadow effect of the insular mountains on Vancouver Island and of the Olympic Peninsula south of us. So keeping in mind that there's a diversity of ecosystems, and I'll use a couple of vignettes or examples from in particular, the coastal western hemlock and the coastal Douglas fir forests as I talk today. I want to take you first, in my first example and discussion, to the coastal temperate rainforest, those wet rainforest types. And here I'm introducing you to one of my permanent research plots. This year, I will be measuring the 30th increment of plots that I established in 1992. And I want to ask you, what do you see in this coastal forest? In this old growth rainforest, you see trees of a range of sizes, complex species. You see strata, different strata of vegetation of different heights, a complex understory, rich in herbs and ferns and shrubs and mosses. We see both living and dead trees, snags in various stages of decay. This complex forest has developed over hundreds of years, leaving behind these structures, unique habitats, and biodiversity associated with them. Now, I want to pose a question that was first presented to me as a master's student. I was introduced to this forest as a climax forest. And so I want to ask you today, is a climax forest the same as an old growth forest? And I think this is a key question because it really gets at our understanding of ecosystems and how they function, which strongly influences our management and our conservation paradigms. A climax forest, by definition, kind of comes from successional theory that tells us disturbances initiate the development of a forest that undergoes a stage of progressive changes in species composition and structures, and that the old growth forest, or the climax forest, is this one at the end of succession where we have complex structures and old trees, but also relatively stable conditions. And that stability, I think, is where we make our mistake. This idea that we have a predictable trajectory that our forests can follow following disturbance, leading to an endpoint that is predictable and unchanging. That paradigm, that 20th century paradigm, guides our forest management, for if it's correct, and we know enough about the site and the vegetation to predict the future, then any disturbed forest, like a clear cut, will recover. And if we maintain the site quality and the vegetation potential, then our management will be sustainable. And so the concept of sustained timber yield and our rotations of 80 to 100 years was based on this very traditional view of how disturbance and succession developed. And it's guided the way that we have changed or altered vegetation. Here is a map courtesy of the Sierra Club of Canada showing Vancouver Island in the 1860s, with the green showing large amounts of old growth forest, and changes over 150 years, largely because of, in part, urbanization, but largely because of industrial forestry. This concept that these forests were predictable in the way they would change and develop, and that our forests would continuously recover. And so we've seen a major change on Vancouver Island in terms of the structure, the composition, and the function of our forests as a result. Now, that traditional paradigm has also influenced conservation, because if in fact our ecosystems are very predictable, and if they will always recover from disturbance, then any unit of nature is adequate for conservation. And that protecting an ecosystem to maintain itself in perpetuity, to be balanced in their initial desirable state, can be done simply by excluding people from the system, putting a fence around it, and allowing the system to restore its balance. And so we've tried that as well. Here, going back to that map of Vancouver Island in 2004, our protected areas are aligned in red. Some of them are very small and difficult to see because, in fact, they're not very large or representative of the larger ecosystems that used to occur on Vancouver Island. And we thought by putting a fence around them and protecting them from primarily logging or urban developments, that we would be able to maintain them in perpetuity. And yet we've seen in places like Cathedral Grove, the provincial park, Macmillan Provincial Park on Vancouver Island, 300 hectares of ancient forest protected in the 1940s, and a Class A provincial park has still been subject to disturbances like wind throw and other damage that have killed trees and changed these forests in ways that sometimes we found quite shocking. And it was because of our assumption about stability in the systems. I want to use a second example and come and also stay on Vancouver Island, but here shift to those drier ecosystems in the coastal Douglas fir zone, where we've altered these forests by, again, misunderstanding how they functioned. Here I want to take you to the Cowichan district on Vancouver Island and talk about research by Dr. Anne Bjorkman and her then master's supervisor, Dr. Velland at UBC and now in Quebec. Today, when we go to this side of Vancouver Island, we see a forest that looks like this, a green landscape with closed canopy, mixed Douglas fir, western red cedar, and maple forests, urban areas mixed in with these green spaces on the east side of the island and on the Gulf Islands. But what Anne did for her thesis was to look at historical land survey records and maps and to use the gridded data set that was created with the township and range system that was imposed on the land to document what was there. And she went back to these records from the 1800s. And in the data set itself, each post was marked with a witness tree, or a tree was sampled. So they figured out what's the species, the diameter, the bearing, and the distance from each grid point on that map. And they determined from that what was the species composition of the forest. And if you look closely here, the forests were described as oak and pine plains. They were described as grasslands and plains, with woodlands being scattered in amongst these open ecosystems. Anne was able to compare the past composition to the current forest compositions and to make comparisons of how the vegetation has changed. She went back to those same points in the landscapes and relocated the trees and measured them. And what she discovered is in the past, we had these pine plains and open grasslands, forests that were dominated either by pines or Douglas firs, and then scattered distribution of trees. And today we've seen increased density of the trees, increased forest cover, a shift towards less fire-tolerant species. And the explanation for these changes is a dramatic shift in the way the ecosystem was functioning. Historically, surface fire was an important part of those coastal Douglas fir dry forests on the east side of Vancouver Island. And we now know from both historical documents, from the oral histories of Indigenous people, that fire was actively used as part of those ecosystems in those dry areas to maintain Garry Oak meadows, to maintain open forests, and to cultivate food plants, cultural plants, and plants that were used for traditional medicines. So here we see the Garry Oak meadows in the 1800s depicted in the red hatched areas, and a photograph showing the cultivation of plants using fire. Well, our land use has changed as a result of the exclusion of fire, and we see the Garry Oak meadows filling in. We see here an aerial photograph showing an infilling of forest into those areas, and a shift then towards closed canopy forests and green spaces that today have a very different species composition, ecosystem function, and as our climate warms, and as we've experienced in recent years, increasing susceptibility to fire. So my take-home message is to ask you to think deeply about the concepts that underlie our contemporary management and conservation paradigms. They're based on very traditional or old views of how disturbance and succession have worked. We assumed that vegetation was reflecting climate, physiography, and soils, and that these were relatively stable and unchanging. We assumed that disturbance history, natural disturbances, cultural disturbances on the landscape were only secondary. And we've often thought that disturbance was negative and needed to be controlled in our systems. We also believe that disturbances were the primary start to a forest and that it ended when the influence of disturbance was terminated. I want to challenge us to rethink about how forests and ecosystems function, to think instead about these contemporary concepts, the idea of complexity, that our vegetation has multiple pathways of being, that they are in non-equilibrium, meaning they are constantly being disturbed and vary in space and time. That we need to manage for processes, not for stable states. That we have to think across scales, and heterogeneity is key. And so our solutions, when we think about how to create resilient landscapes, is to manage for multifunctional landscapes, resilience to climate and the climate-mediated disturbances. And that means diversifying species on our landscapes again, diversifying our silviculture, our management paradigms, but also to be actively restoring ecosystem composition, structure, and function. And that's going to mean active management in many of our landscapes, including those that we have tried to preserve and conserve in some places by excluding key processes. And finally, we need to learn to adapt to the mistakes and the surprises coming to us because of global climate change. Thank you.
Dr. Daniels, we have a couple of questions, but I think we just have time for one. So the one question that we can look at is, when we look at active restoration needed, for example, in the CRD, in the parks that we have here, how do we finance something like that to reestablish complexity?
How do we finance the restoration efforts?
Mm-hmm.
I think that's a fantastic question, and I think it depends a little bit on which components of the ecosystems where and how what we are trying to achieve. So in some cases, when we are talking about restoration of the systems, we're looking in some cases about removing some vegetation, creating opportunities and using tools to restore the function of the systems. In some cases, there are grants and opportunities to do that. In particular, in landscapes today where fire and fuels have accumulated, there's opportunities and funding available to communities to do some of that restoration work, while also mitigating against risk of fire in wildland-urban interfaces. And then in other cases, it's going to be more of an ecological purpose, in which case we're probably looking for funding from either governmental or sometimes non-governmental organizations.
Excellent. Thank you very much. It's been very interesting. I'm sure there'll be lots more questions coming your way at the end of the session. Thank you.
Thank you.
Okay, we'll go on to our third presenter. Our third presenter is Dr. Gary Merkel. Dr. Merkel is a member of the Totland Nation in Northwest BC. He's a registered professional forester with over 45 years of experience in the field, management, academic research, and community aspects of forest and land management. He has worked in many fields, some of which include organizational development, community development, business development, and management, governance, community-based land management, and education. Dr. Merkel was one member of the two-person independent panel that conducted the province of BC's Strategic Old Growth Review. Welcome, Dr. Merkel.
Thank you. Thank you. Let me just get my thing up here. Is that working?
Yes, it is.
Great. I'll apologize to everybody right off the bat because I work off satellite internet where I live, and I might have the odd burp, but shouldn't disappear. I've never disappeared yet. Thank you. I'm joining you from the homeland of the Danacha, who I live with now. And you see on the screen here, Kiakunik is my Danacha name. It means fish person. I come from fish people, the Tahltan people in Northwest BC. My name there is Nadikanaza, means strong land. We have fish there, so they call me a fish person. So today I'm going to talk about how do we improve resilience, and I won't go into detail. And then more importantly, how do we actually do this and try to make it real in our world? Just a couple opening thoughts here. First law of intelligent tinkering, save all the parts. Secondly, and this theme's going to happen a lot, you can either adapt or perish. That's nature's way, and there's no getting around it. But this one here is one that I want to speak about a bit as we move through this. This is a Lakota proverb, and we do not fear the things in the dark, yet we fear the dark. We do not fear the search for the truth, yet we fear the truth. We will talk around it all day, but we will never actually say it out loud, the real hard stuff. because it's a human survival instinct, and I'll explain that in a minute. So how do we actually improve our resilience in this climate change area? Many of you will be aware that we speak about both adaptation and mitigation in climate work. One is adapting to our new reality and new world. The other is mitigating the effects of this new world, building larger culverts to handle bigger stream events, that type of thing, and trying to mitigate the impacts. All of this, so when you're working on a landscape, is informed by continual vulnerability assessment and track. In my community, we track some parameters, and we're actually tracking a couple more right now, and continuously estimate the vulnerability of our landscape. What's its exposure to change? What's the sensitivity and adaptability or adaptive capacity of our ecosystems? Which ones are more able, less able, and of the various fish, wildlife, and plant species. Unfortunately, where I live, the species that are least able to adapt are the ones that we most depend on. So in terms of adaptation, Lori spoke to this a bit. We have a strategy in British Columbia, and many other countries are looking at this, is shifting to more drought and heat tolerant species in some of the core places, using multiple species to try to keep your diversity high, and so your mix in theory will be more resilient. You're trying to cover your bases because you don't quite know where all of this is going to go. This is all really educated guesswork, and so it's like any educated guesswork. It requires you to cover your bases, is the way I think of it. In terms of ecosystems, it is now reasonably, I don't want to say easy, but there is a lot of good science around being able to map very localized ecosystem shifts that you can expect from climate change. We have good enough climate maps on the Earth to know where it's going to be a bit hotter, a bit wetter, a bit whatever, and what we expect the future climate to be. And so you can really start to shift your silviculture systems and your forest harvesting to work towards those predicted ecosystems and how they're going to shift. Another big adaptation thing, and particularly Indigenous communities, is this is a real culture shock, I'll call it, in many communities that depend on the land, and you really have to start to learn about new sustenance species. Your predator-prey relationships do change with climate change. In my homeland, we have a wolf moose predator-prey, but it is slowly shifting to a coyote, deer, and elk. You also have to change your travel pattern. This is particularly true in the boreal. And there's many other adaptation things we can do. I just am skimming the surface. In terms of mitigation, what we try to do is we try to defer and lessen the impacts or stretch out the impacts of climate change. So it gives us a bit more time to build a new kind of a ecosystem structure across a landscape. And that sounds like engineering at its grandest design, but that's really the way you almost have to think. We use very interesting, we try to do different silviculture systems when we're doing forest harvesting, particularly on coastal sites. We used to be able to plant cedar. It's rare that we can plant cedar anymore and have them survive. They're turning out like interior Douglas fir. If you open it up too much, they get too hot and they just die. A lot of what Bill talked about. So you really have to maintain cover to actually get areas to regenerate. In terms of mitigation, you try to maintain as much of your refugia as you can, areas that you predict will be least impacted by climate change, so that you have a lot of remnants of that old landscape left. These tend to be wetlands, they tend to be shaded areas, canyons, moist areas that in theory will be impacted slower and take longer to shift. You try to keep your pieces relatively, your parts and your pieces and your process relatively intact on your landscape. This is fundamental to good ecosystem management anyways, but resilience tells us reshape your system to what it's supposed to be and try to keep it reasonably intact to buy yourself some time and engineer the shift to the new ecosystem. And then we can do more focused things like managing our stream temperatures, wider riparian areas, conserving wetlands, planting streamside vegetation, etc. But all of this stuff is all the technicalities. How do you actually turn it into reality? And that is a complex question. It does really require a multi-level approach. It requires a societal shift, certainly at a societal level, and it requires political will. Everybody says, well, government should do something. Well, all of you see what happens when government tries to do something too fast and goes ahead of society. They just get kicked out and somebody comes in who's almost the exact opposite. So we have this rational mind that doesn't allow us to accept all of the things we're doing wrong at any given time, because it would probably drive us crazy and we'd all end up in the loony bin. So we can have this ability for mass denial, which is a really interesting human behavior. We also need a number of systemic priorities. When we wrote the Old Growth Review, we talked about a lot of these. Make ecosystem health and managing for biodiversity risk a priority. Do forward projections for climate change. Do total area planning. Change your rudder from this flip-flop elected government to something that's much more grounded in collective wisdom and broader public. Build our level of awareness and way up and etc. I won't go into a lot of these details here, but what I do want to advocate is that we do have to start learning to think like ecosystems. And there's a lot more information in these slides that I'm going to present, but you can have these slides. I've prepared them for reference for you. You have to think over long time frames. You have to think at big scales. You have to think parts and processes, and you have to look at what nature is doing and try to mimic that as best you can. Maintain connectivity, maintain the integrity of these systems. That is a whole different way of thinking than we do now of looking at trees and forests. It's a very different way of thinking, and we're really working hard to shift our paradigm right now to flip over to this thinking, but it is a very difficult shift. Paradigm shift, just quickly, that's a whole, when you change your view so much that it results in a huge change in your thinking. It starts with individuals, it grows to groups, and then it becomes society. So it starts with every one of you, it starts with every individual. And it can be actually facilitated through building common language, building understanding of the new paradigm, like what we're doing now, building structures that reflect that paradigm so it becomes normalized in your work and everyday life, and celebrating your progress, celebrating your, and keeping a sense of momentum that we're actually making change at this big scale. But the big thing is, this starts in your mind, and then it turns from there to action to reality. Critical. And it starts with government. So us, part of this paradigm, there is a lot of parts, but I want to just mention a couple. First off, humble. Knowing our place and knowing what we don't know. And we don't know a lot. In fact, we know almost nothing. We confuse ourselves. We get comfort by pretending we know more than we know. but we really know nothing. You can study a flower for the rest of your life and never know that flower. We need to have the courage to learn to now speak the truth and not avoid the issues that we're dealing with. And this is a societal thing that's going to probably be difficult for us, particularly in Canada. And again, being truthful about the fact that we don't know and that we are running out of choices. Every year or two that goes by, every decade, we run out of choices because we're eliminating our choices as we move through this path. We have to learn to accept our smallness. We have to start thinking ecosystems, and we have to accept our reality. And you know what? I love this. I'm not in denial. I'm just very selective about the reality I accept. Couple closing thoughts. This species is a bit too smart for its own good. And maybe the reason, to quote an author friend, maybe the reason we haven't found any other high-powered alien civilizations is because they're unsustainable and don't leave enough of a trace for the rest of us to even find. This is a transformative change. This is here to stay. It absolutely requires a paradigm shift to fuel the change. It's going to take some time. Enlightenment doesn't happen overnight. We are not alone in this country, this planet. Many people are struggling with this and trying to figure out how to deal with it and look after their forests and their lands better. It does require all of us coming together and making this happen. And really, there are no enemies out there, just frightened people. And maybe they're frightened for the wrong reasons. Well, maybe we got to manufacture that fear to the right region. Or maybe a few more catastrophic. The land always wins in the end, and we're part of the land. We don't own the land. We're not above the land. We're part of it. It always wins. So finally, this I just want to leave you. Huge change, but it's not the strongest of the species that survived, nor the most intelligent, but the one most responsive to change. And for those of you who will have this presentation, I included a little extra slide around earth-based thinking, because this is part of where I think we need to go. It speaks about words and concepts that don't exist in earth-based languages and the belief that causes that not to exist. I'm not going to go through this, but it might tweak some of you to start looking at this and thinking, maybe there's some good thinking in there that's worth all of us looking at. That's it for me. Medu.
Thank you, Dr. Merkel. So much there. I think we definitely did not have time to go through all of that. Thank you. I think we'd spend a whole hour with you. One question that's come up, and I know it's important here in the Capital Regional District, where we have some lands that are important for different wildlife, but how can you explain a little bit more about how we can maintain refugia, especially for the large animals that are still trying to make this our home?
So refugia, like anything else, requires us to take a different approach to planning. You have to now start planning at an ecosystem level, and you need to plan area-wise, and you need to include all land uses. This is not just forestry anymore. One of my slides, I never got time to go into it, but if you make ecosystem health, biodiversity management a priority, then now all sectors have to conform to that. I build a total plan for my whole area for 1,000 years, and I say this is the way I'm going to grow it, and this is the way I'm going to, what's it going to hang on to, and I work within that. That sounds a bit idealistic, but that's frankly what you have to do in the forest sector, and that's how you have to expand it to other sectors. Otherwise, it doesn't happen, and we get killed by the death of 1,000 cuts.
Absolutely. Again, thank you very much for your wise words. I think we're bringing the whole panel now. Excellent. Okay, on so many questions and not much time, but I'm going to talk a little bit about what you've all talked about, paradigm shift, and you addressed it in different ways. So maybe each of you take a little bit of time and talk about your work and paradigm shift and how that relates, and especially how changes can be made in the paradigms through the lens that you're looking at. Bill, let's start with you.
Sure. I will just say I was really impressed with the way Lori framed that, with that kind of Gestalt diagram. It took me a while to see both of them, but there are so many different ways to look at the same thing. When it comes to tree mortality, and it's being driven by climate for a long time, drought has kind of been at the center of that. There's even an acronym in our research community, DIM, or drought-induced mortality. And it's only recently that we've really undergone a real paradigm shift to say, oh, well, heat can push things in this direction too. And because warming and especially intensification of heat extremes are some of the more high confidence factors that we know are coming with ongoing global change, this is something that's been, I think, a big shift in our field. And yet there's still, I review papers every week where we refer to the phenomenon as just drought-induced mortality, as if the planet's not warming ever still. And so I think there's still ground to cover there in both our research community and how we think about this phenomenon.
Thank you, Bill. And Lori, I'll go on with you, but I'm going to add one more piece to that, is the question is, we're talking about paradigm shifts, but it's not just a platitude. How do we make that into a reality, especially when we have many structures in place like the Forest Act that reduce our mobility? So maybe include that as part of your answer.
Yeah, well, personally, I think the Forest Act still needs to make some dramatic changes in British Columbia. And maybe if I can take a step and kind of link to what the good points Bill just made. Here in British Columbia, we are seeing drought-induced mortality in our forests across elevations, forest types, on the coast, in the interior. So here in coastal British Columbia, we are seeing, in particular, western red cedar and yellow cedar are subject to climate change-induced mortality. Western red cedar, we're getting reports from all through the coastal region about increased mortality rates and concerns about canopy dieback of trees. Yellow cedar, we see on the north coast, there's 400,000 hectares of declining yellow cedar forests in northern British Columbia and Alaska that are driven by climate change. It's a complex system there where the change that we're seeing in those systems, because of what's happening is with warmer climate, there's lower snowpacks. The snowpack is required to protect the roots in winter. So we get cold snaps that still occur in early spring that are freezing the roots. And then ironically, yellow cedar trees are dying of drought in the rainforest. So warming climate, but extreme cold temperatures still, in absence of snowpack, are combining in this very complex way. So maybe I can use that as a segue then to more generally answer the question about the complexity and the interactions of climate and climate interacting with disturbances to impact our ecosystems and our forests in particular. We know that there's multiple stressors on forests, and which stressors are influencing the forests vary in different parts of British Columbia and even within the coast, whether we're in the dry belt, the interior coastal Douglas fir forest types, or if we're in the coastal western hemlock forest types, because of that steep moisture gradient west and east on Vancouver Island. So thinking about what are the other stressors, what are the stressors for which we have greater control? What are the factors that are contributing to stress in trees that make them susceptible to this drought-induced climate change and drought-induced mortality that allow those trees to become more resilient? And so that's really a kind of a different way to think about the systems and to think about the multiple stressors and to start changing and controlling the ones that we have greater control over. And I really do think that the examples that I chose were to try to illustrate to people that our ecosystems have changed quite dramatically in the last 100 years, largely because of people. So we are both adding and removing disturbances that are integral to the systems, but also we are pushing our systems outside of their historical and adaptive ranges of variation. And so, we need to be cautious. We need to have better understanding, empirical understanding about our systems. I know, Gary, I don't want to disagree with something Gary pointed out is, understanding ecosystem function. And we use the natural disturbance types to guide much of that thinking in BC. But I want to point out the natural disturbance type for coastal BC says that our coastal rainforests burn at a standard placing disturbance on a cycle of 250 years. That is not empirically based. We do not have a 250 or even a 350 fire return interval in these coastal forests. That was misinterpretation. There's empirical evidence from the paleo records, from the historical oral histories of Indigenous people, from the age structures of individual patches and entire landscapes of forests that tell us that's not how fire worked in these systems. And so choosing to manage timber on the concept of a 250-year fire return interval is actually one of the stressors contributing to the landscape problem. So if we are unwilling to let go of the knowledge that we held in the 1990s when we created that natural disturbance type system, if we're not willing to take the best knowledge that has improved upon it and translate that into policy and practice, we will continue on the path that we're on now, and it's not okay.
Well said. Gary.
The question was around what is the paradigm shift and how do we make it happen?
Yeah, and at all different levels, from the self. I know you talked about the whole idea from the self to the government, but we have the self and we have all the way to legislation. So just your thoughts on what should happen? Should it all happen together? Something should be done on the ground first, etc.
Facilitating a paradigm shift is, you cannot change paradigm through regulation. Paradigm changes because people change their thinking. In British Columbia, and this happened in a few other places in the world, a very similar thing. We made a bike helmet law. Nobody wore a bike helmet for quite a few years until they started showing pictures of kids and others having their skulls crushed at very low speeds. And then some people started to wear it because we wanted our kids to wear it. And then all of a sudden wearing it was not a good thing. And nobody enforced it. We just started doing it. And we do need a shift. In most countries, British Columbia is no exception, we manage for resources subject to constraints. The land is all about resources and we can use them however we want as long as we take care of some constraints that are important to whoever raises them. Mainly like timber, you can manage for visual and a few other things, but they can't impact the timber supply. You can't impact the resource use more than a certain amount. We have to shift that to managing for ecosystem health. We think by managing for timber subject or resources subject to constraints, what we're thinking is that we're the center and the land's there for us. And we can use it how we like as long as we watch out for things. Well, no, it doesn't work like that. If you look after the land, take care of the health of the ecosystems, it will look after itself and look after you. We are part of it. We are not above it. This is the kind of paradigm that needs to be shifted. We need to definitely move to a place where we're just a small part equal to everything else. We don't own any of this stuff. It owns us. That kind of thinking is essential to creating the right kinds of management regimes. How do we do that at a global scale? I wish I knew. Our species is so darn smart. Like I said, we're just too smart for our own good, and we find ways to wiggle around and work out of these things that, maybe 50% of the countries do it, but 50% don't. And that 50% don't is enough to keep everything off the rails. So I mean, we know how to do paradigm shifts. They have help facilitate those at a large scale on some really big topics. I know the process. I know how long it takes. I know a lot of that, or at least I know generally how to do it. There's a lot of bumps and weaves as you move through it. We are working through that process. I mean, look, but Lori's right. All of our management tools right now reflect our current paradigm. Timber is what we buy in British Columbia. The timber bias is a very deeply rooted cultural bias. We built this province on the backs of timber. And so it's hard to get over that in everything we do. And our understanding of forest is all about timber. So, you know, I know that's a bit of a one, but for me, it's step one. Change your thinking, or otherwise you're just putting lipstick on the pig.
Thank you,
Gary,
Gary.
this gets away from kind of our coastal systems, but Gary, I wondered if your impression is that we've learned a little bit of that lesson in places like the Caribou-Chilcotin or part of the Lakes District that were affected, you know, where we burned 1.5 million hectares of forest in 2017 and 2018 with huge consequences to forest management. They lost 10 years of sustainable timber supply in the Caribou region. You know, we talk about a regional district and communities that are looking at economic losses for multiple generations of people and needing to shift their entire way of thinking about those forests. And that's anywhere from homeowners to municipalities to First Nations communities, including the forest industry, who's talking about how they need to rethink what they are doing. And there's an area that was first hit by mountain pine beetle, a fall down effect. The midterm timber supply is so highly concentrated in that area, and then these catastrophic fires on top of it with life-altering effects for those communities. There's a place where we learned a very hard lesson in multiple steps, and the paradigm shift has to occur in that landscape because it's simply not possible to sustain the type of forest management and timber production that we had envisioned for that landscape, or that had been envisioned for that landscape prior to 2017. And so I think there's lessons that we can be learning even from different regions in the province. How do we avoid that same catastrophic effect in the Okanagan, on the island, in southeast BC, in the north of the province? You know, there are lessons that we could be learning from one another. And they're hard lessons for us to learn. We're short-term costs for a long-term benefit.
Was that a question, Gary?
Well, I do. Yeah, Gary, I wondered if you had some thoughts on those kinds of lessons that we might learn internally within different parts of BC.
Well, we were already in trouble in those areas because of the way we're managing anyways. By stopping fire and not allowing ecosystems to stay in their inherent patterns, we created massive areas of stagnant forests that were ripe for fire, disease, etc. Then and so we were already going to see massive AAC reductions in those areas, many below our long run what we thought was sustainable. But I still see people blaming the small pieces. Like I sat in meetings where people are blaming deferrals for this problem, or leaving riparian that causes the fire to go across the landscape, or all these things. There are a lot of people who are learning though, and we are. I just, you know, I have to be optimistic in my work, or I would never do my work of trying to shift paradigm. And I do see a lot of people going, we see the mistake there. But when I talked to the people who did that clear cut in central BC, they said, we never planned on doing the world's biggest clear cut. We just were chasing pine beetle, and all of a sudden it ended up being something you can see from probably Mars. I don't know. And it's so friggin' big. And so I that process that I laid out on the slide, we shifted the paradigm in the Columbia Basin to have people think about basin culture. And we did that by first off building common, easy language that everybody understood, building their understanding of the basin. And because they all were part of it, they started to connect to each other. support each other. We built a lot of structures that reflected the concept of Basin, the Basin Environmental Educators Network, the Basin Culture, Arts and Culture Alliance, etc. We built a partnership with the U.S. to start thinking and managing Basin. And then we started to celebrate Basin, and we started to celebrate our progress in actually thinking and working Basin. That's one example, and now it's common in Basin for everybody to think like that. It's that kind of an approach that you actually have to do. I wish I could just go poof, you're enlightened. I just wish it was that easy. I wish I had a pocket full of magic bullets.
I think we all wish you did too, Gary. I think I'm going to have to call this to a close. We're over time, but and I wish we could keep talking this moment. Very amazing thoughts that have come through, and you've definitely enriched my knowledge and my mind today. Thank you all. Shauna?
Yeah, just echoing some of Nithya's sentiments here. A big thank you to Bill, Lori, and Gary for joining us for this third Project Teach session and sharing your invaluable expertise with us. It was such a rich conversation. Thanks to everyone who's tuned in and stayed with us for 11 minutes past our scheduled time. This will be available for rewatching and sharing immediately after the broadcast ends. Our next session, Connectivity Conservation, featuring Angela Brennan, Mead Crosby, and Chris Morgan, will be at the same time next week, June 2nd, so please tune in for that. And finally, please consider registering for the in-person solutions session on June 23rd at the University of Victoria. That will feature a native plant walk to begin, an all-star panel facilitated by Andy McKinnon, and it will aim to mobilize some of the lessons learned in sessions like this one. So with that, I will bid everyone goodbye. Have a great rest of your day.
Bye, everybody.
Thanks, everyone.
Thanks, everyone.